Welcome to Ms. Taylor's Geometry Notes. So today we're going to do notes a little bit differently. I'm going to kind of walk you through some problems while you're looking at the summary of what's going on, and then you're going to do some more practice problems at the end of the notes to make sure that you know what's going on. So remember that when we talk about corresponding parts, that means that if we have when we have corresponding parts, we have to have our similarity statement. In this case, our tilde or our squiggle means similar. And so similar means that they have the same shape, but they're not necessarily the same size. So we might have one right triangle that's a little bit smaller and one right triangle that's a little bit bigger. So we talk about corresponding parts. We're talking about the same angles in the same positions, the same sides in the same position. So we're going to use that information that we're given to find out information about similar polygons. So here they tell us that triangle RST is similar to XYZ. So that means that angle R, because it's the first letter, is congruent to angle X. Because in similar polygons, angles are congruent, sides are proportional. So then I know that S is congruent to Y, and then I finally know that T is congruent to Z. And so we don't know that sides are congruent, but we know that they're proportional. So I'm going to put triangle RST on top, and then I'm going to put triangle XYZ on bottom. So the first thing I'm going to do is I'm going to look at sides RS over XY. So I know that RS equals 20, and I know that XY is 12. So this right here is our scale factor or our ratio. Now we also want to simplify this, so I know I can divide both by 2, and we get 10 over 6, and I can divide it again. That's a 6. I don't know why I wrote a 2. And we get 5 over 3. So our scale factor from RST to XYZ is 5 to 3, and we can write that as a fraction, or we can write it as a ratio, and occasionally you can see it written as a fraction, which would be, or a decimal, which would be 1.6 repeating. So all three of those represent our scale factor. So we've already marked, so that's that first part. We've already marked our set of congruent angles, and now we're going to write the ratios of the corresponding sides. So that's RS to XY. Then we're going to do ST over YZ. And again, I'm getting these from the similarity statements. So ST is 30, YZ is 18. And divide all those by 6, and we get 5/3 as our ratio or our scale factor. And if you were to do the other one, you would get it the same. So again, in this one, they give us our similarity statement, and they want us to find the scale factor. So I know that angle J is congruent to angle P. I know that K is congruent to Q, and then I know that L is congruent to R. So we're wanting to find the scale factor, so I'm going to put triangle JKL over triangle PQR. So I'm going to start with JK over PQ. So JK is 6, PQ is 9, and so that's going to simplify to 2/3, which is RK. And if this is truly similar, if we were to do the other two sides, we would get our scale factor is 2/3. So I want you to go ahead and, we've marked our congruent angles, so we don't need to list them. We've written our scale factor, and then I'm just going to do one of the ratios because I know that they are similar. So how do we find the lengths in similar polygons? So if we notice here, we're missing EF, and let's just make sure that EF should be proportional to NP. So I'm going to put EF over NP, and then I'm going to write down my ratio of the corresponding side length. So now I'm going to pick any other two. So I'm going to pick DE and MN. So DE is 15 and MN is 18. So we said earlier that sides are proportional. So what we mean by that is if we set our two scale factors or our two sets of sides equal to each other, then we know that they should equal each other. So this is where we do our cross, multiply, and divide. So we do, real quickly, we do 30 times 15, and we get 450 equals 18x, and then we're going to divide by 18, and we get 25 equals x. So side x equals 25. And so that's what we mean by they're proportional, is we can cross multiply and divide and find the missing side. So again, here, our x is KL. So KL is going to be matched with HM. So I'm going to put HM on top of KL. I know that HM is 12. I know that KL is x. So now I'm going to find another pair of sides. So I'm going to go GH and HK. So GH is 10 and HK is 15. And so now we can set them equal to each other as a proportion. So 12x equals 10 over 15. Let me make that actually look like a number. And then we cross multiply and divide. So we get 10x equals 180. We're going to divide by 10, and x equals 18. So that's how we find the missing side if we know that they are in fact similar. We're going to skip that one because you should have it down. So for perimeter, when we talk about perimeter, perimeter's scale factor is simply K. So K is the scale factor. Oh, I can't spell today, guys, sorry. So they're going to build a new swimming pool, and an Olympic pool has a length of 50. Oh, they've drawn us one, and a width of 25. So the new pool is going to be similar, but it's going to have a length of 40 meters. So we're looking for our missing side, and we need to find the perimeter. So I'm going to start with my Olympic pool, and I'm going to put the large side over the small side, and then I'm going to start with the new pool, which is going to be 40 over x. And so we're going to cross multiply. So 25 times 40 is 1,000 equals 50x. And then we're going to divide by 50, which gets us 20 equals x. So we know that 20 equals x. So we know that the perimeter of the Olympic pool, we know that perimeter, we're just going to add all the sides together. So that one's 50 meters. That one's 25 meters. So it's going to be 150 is going to be the perimeter of the Olympic pool. And then the neighborhood pool, or the town pool, we're going to go 40, and 40 is 80, plus another is 120. And again, those should both be in meters. And so our perimeter is just, it's the same scale factor as the sides. Nothing changes, nothing's different. So your neighbor's going to enlarge a garden. The garden is a rectangular with 6 by 15. Let me actually put those in the correct spot. The new garden is going to be similar, but it's going to have a length of 35. And then what is going to be the perimeter of the other one? So we can do this, yeah. So I'm going to go 6 over 15, or sorry, no. Oh, my brain is not working. So we're going to go the width over the width, and then the length over the length, and we're going to cross multiply and divide to find what we're missing. So we get 15x equals 210. So we divide by 15, and we get x equals 14. So we want to find the perimeter of the enlarged garden. The original garden, or the OG garden, is going to be 30 plus 12, which is 42 feet. And of the enlarged garden is going to be 35 times 2, which is 70, plus 28, which is 98 feet. All right, so area is very different. Area, we're going to take our K or our scale factor, and we're going to square it. Because when we do area, it's length times width, and that always equals x squared. So they're going to give us the area of one, and we're going to need to find the area of the other. So they give us the area is 36 centimeters squared. And again, your hint is that square on the centimeter. Area is squared. So we need to find the scale factor first using our 10 and using our 5. So I'm going to simplify this, and our scale factor, or our K, equals 5. So when we're doing area, it's very, very important for us to square the scale factor. So if 5 is our K squared, or our 5 squared, oh my goodness, is going to equal 25. So our area K, our factor is 25. So I'm going to put 25 over 1, which is our scale factor, and then I'm going to put our 36, which is the area of the big triangle, and we're going to put x right there. So now we're going to cross multiply, and then we're going to divide. So we get 25x equals 36. And so once I get 25x, I'm going to divide 36 by 25, and x equals 1.44. So we should be able to go 1.44 times 25, and we should be able to get 36. So our area of our smaller triangle is 1.44. And again, the biggest difference with area is we have to square the scale factor. Have to give the square the scale factor. All right, those are our notes. Oh, nope, we got one more area. I thought I had one more planned for you guys. So the area of RST is 75 square meters. We want to find the area of PQT. So I'm going to put PQT on top of RST. And so PQ is 14, SR is 10, and so we end up with 7 over 5 as our scale factor, or our K. But for area, equals K squared. So we're going to take 7/5 and we're going to square it. So 7 squared is 49, 5 squared is 25. So they gave us RST, which is the bottom when we did our scale factor. So we're going to put the X on top, and we're going to put the 75 on bottom, and then we're going to make it equal our area scale factor. So now we're going to cross multiply and divide. So we get 25x, and then 75 times 49 is 3,675. And then we're going to divide by 25, divide by 25. And x equals 149. And so that is our area of PQT.